Okay, let's see. Is this sound big enough? Can you hear me? Okay, I can actually see you. This is pretty good. That's excellent, and it's a good crowd. It's been a little while since I've given talks with COVID, kind of keeping us all in our houses. I did give some talks over Zoom, but it's so much better to see your faces and to be here. Let's see, maybe I'll get rid of this. I don't know. I'm here to talk about making coding fun. So fun, rah, rah, ha, ha. Yeah, I think so. I mean, if you're going to do coding, you're going to do it for your life. You're going to do it for a long time. One of the things you see in Python is actually some gray beards. I had to grow a beard to get some gray. You see some people who are actually been around for a long time. That tells you something. It tells you, one, they're having fun, because you don't do something for a long time unless you like it. That's one thing that won't happen. So people are liking coding in Python or coding in general. So I'm going to go quickly, just a little background. Some of you, why I ended up coding, because I did not start my career as a coder. I actually, as much as people want coding, there's a lot of life out there, and I think coming to coding from science actually helped me, in particular, do what I wanted to do. So I studied satellite scatterometry. Then I went and did medicine, medical imaging, and that led me to more coding, and that led me to Python. It's actually doing medical imaging that's the reason I did Python at all. Then I went and was a professor for a little while, did electrical computer engineering, taught inverse problems. AI is included in that inverse problems category. Taught electromagnetism, taught deep applied mathematics, loved it. Then ended up starting to write a lot more software. So during that time, you can see like my brief history of Python life started really pretty early on, where Python was started in 1991. I came in 1998, Python 1.4.2. There are people here who are earlier than me, actually. But I'm one of the old timers in terms of using Python for a long time. And just done a lot of different things. On the top are different organizations I've been part of and trying to create, and then on the bottom, different projects that I've been a part of in some way or another. My academic career quickly changed as I was writing a lot more software than papers and doing a lot of community building too. So a band of us basically got together from 1998 till today, and we wrote a set of libraries called SciPy. That led to a movement, actually, that continues in the PyData movement today, so the SciPy data movement. And then, looking back, you can start to see the impact we're starting to have. We had a tremendous impact, but it hasn't come quickly. It's taken a long time to fruition. I think that's one of the messages about making coding fun. If it's fun, you're going to stay with it. And remember to be patient. While there's a lot of demand for coding, you're going to go in and code a little bit. Don't think that it's going to take you a few weeks and suddenly you'll be a great coder. It's something that could take years. It's something you commit to and something you then do for a long period of time. But by doing that, you can have a huge impact. So our friends, the friends of mine that kind of get together and we put SciPy together, and then NumPy came later. Lots of people depend on this now. It actually blows me away. There's a research done just studying all the archive papers. I don't know if you know what archive is. It's a place where a lot of PDF, if you're a scientist, you know what archive is. It's a place where papers are published. Look at all those PDFs, and you look at the tags for the images that are put in those PDFs, and you can see who uses Matplotlib, which is one of the SciPy stack papers. If you use Matplotlib, you're using NumPy, and probably a little SciPy too. Effectively, almost 25% of all science uses this stack. Now, I'm aware of some of the anecdotes, the black hole that was imaged, the interferometry, the gravitational waves at LIGO that was discovered. It was amazing to meet the scientists involved and realize they're using these tools. It's had a huge, huge impact. So part of what I want to communicate, how do you have this impact while having fun? It takes patience, persistent collaboration. So I showed that timeline to kind of help you understand. I've been doing this a long, long time. Since '98 was when SciPy first started to become materialized. It wasn't until 2020, actually a paper was finally published that would have satisfied my academic overlords who wanted me to write papers. They would have been happy with this publication, I can tell you. But it took a long time for that to come to fruition. Unfortunately, to the good work of a lot of people, that's the other reason I put the slide up here, because it shows all the people that are actually involved. Sorry, not all the people. A portion of the people that were involved. And then also, it's kind of like, how do we get there? How do we do that? Phase one, change the world, make the world a better place by doing something you love. 2, figure out how to make a living doing it. That's been a journey I've been on for a while. And now, phase 3 is what I'm really focused on these days, is how do I build organizations, other people, investment patterns, so a lot of people can both change the world by doing something they love and financially benefit. So this is just, I get asked all the time, what are you doing now? And so I'd like to just show, this is what I'm involved with right now. And this is what I've tried to do here is just capture a few of the people and the projects and the people helping me do those projects. Because if I sit there and explain all the things I'm involved with, of course, people go, how are you doing all this? Well, I'm not doing all this alone. I'm trying to help other people get there. So you'll hear, I think Peter's going to talk later. Fabio works with Peter still at Anaconda. That was one of the key things. I like to, Peter's continuing to lead Anaconda and doing great things from where we left it together. And then NumFocus has been a project we've both been working on for a long time, but here are the people, some of the people still involved. QuantSight's a consultancy that I run, QuantSight Labs, open source special network. I'm not going to go into detail about all these things. If you're interested, please come talk to me. I'll go into as much detail as you like about any of these topics. But I'm here to help. I'm here to help people raise money, get money connected to talented people who are going to change the world. Because the big, right now, making coding fun is an excellent topic. I'm going to go into that right now. But critical to when you do coding is making sure the right people are getting the funding that makes things happen. It doesn't always happen like that, so I'm happy to help. Happy to help make sure the great people out there doing amazing things get the money they need to continue to do those great things. That's basically my mission. So when you think about making coding fun, I think about this chart. Some of you have seen it. Ikigai is a concept. It's a Japanese word, kind of a reason for being, reason for life. What's my purpose in life? I think about that a lot. I'm actually a philosopher. I think a lot about what am I doing. I'm actually pretty philosophical. People that know me, I kind of think about that a lot. What's the point? What's the meta point? I like this because it's a meta point that I've resonated with multiple times. If you are doing things, there's 4 areas. If you do what you love, what you're good at, what the world needs, and which is related to what you can be paid for, not exactly correlated. But if you can find the sweet spot of that, that's an amazing reason for being. And I think coding can certainly be in the middle of that if you balance all the pieces together. If you're just, what the world needs, what you can be paid for, you're just vocation, yeah, that's fine, but it's not as great as if it's also what you love and what you're good at. And so making coding fun is about shooting, so at least 60%, I like to think 75, even more, of your time is spent doing what you love. It's going to take you some time to figure that out, so don't assume that after a week, oh, I hate this. No. Give yourself a little longer than that. Give yourself 6 months, a year, 18 months, but eventually you have to decide, is this really resonating with who I am? And if it is, continue. If not, switch, do something else. Life's too short to be spending too much time doing things you don't love. Just remember the time constant there. This isn't hours or days. This is months and half years. So here's my overall general topic. These are the different areas I thought about. I'll go over kind of each of these quickly. I don't have a lot of time, but we'll hopefully learn something along the way about how to make coding fun. So first of all, use Python, of course. That's the way you're going to have making coding fun. And in particular, I'd say use interactive Python. Like Python from the beginning had what's called a REPL, a read, eval, print loop. A terminal, you can go in there and just type as a calculator. What I didn't realize until later is just how critical that is to making Python help fit your brain. Because by using the REPL, you can get in with the data you have. You can try code out. It's kind of a way of doing test-driven development. You're doing experiment-driven development. Instead of writing a whole big path of code and hoping, you're basically developing as you go. And so the REPL is critical. In fact, there's a really good one called IPython that was created later, interactive Python, that led to the creation of Jupyter, Jupyter the project. Some of you have heard of Jupyter notebooks. But beneath Jupyter, there's a protocol for interactive Python that's even more important, I think. Notebooks are great. There's lots of versions of them. But the protocol for interactive Python is really cool. So use interactive Python. Then you can start doing things like building applications on the fly, kind of having coding. Some people want to even take notebooks and have that be the code. I'm not one of those people. I think it's a great place to experiment and a great place to create solutions and reports, but then you do want to have libraries that come out of that. So use interactive Python. This one is kind of like make coding fun by having interests besides coding. First of all, have a general thinking about other things in your life. Have passions, have interests. Be curious about more than just code. And coding, if you are coding on things you care about, it's a lot more fun. So care about other things. That takes kind of some experimenting, getting used to the reading, hanging out with friends, figuring out what kind of things you like. In my life, I found that I love math. That's kind of where it started for me. I kind of have this little dial, show these arrows, trying to see the kinds of things I'm interested in, how it kind of led to one to another. So coding kind of shows up, later with Python and open source, kind of after medical imaging, after electromagnetic waves, after applied math. Then it was easy to jump involved with coding because I cared about getting a result. I could spend the long hours tediously writing the C++ documentation for numeric that led to my involvement with NumPy because I cared. I wanted the thing to be, I wanted to do something that mattered that in my other life, part of life I cared about. So all of you have other interests, and your coding will be fun if you care about those interests. So get other interests and care. So learn. I have data structures and algorithms here, but this is a little story first. You do have to work hard. Like, coding can't be fun if you're no good at it. Coding can't be fun if you don't know anything about the stuff you should be doing. And it takes some effort to get to know this. So I played basketball, and I also sang in choirs. I hated running bass lines on basketball. I don't know, these intervals. You had to run baseline to baseline. Different groups call it different things. But I hated it. But then I sure had more fun in a game when I could actually run and continue in the whole game. I can't do that anymore. I'm a little older now. But I used to be able to run a whole game. But it was the practice. It was the doing those intervals and conditioning that actually led to that. Coding is similar. You have to do things that help you get better at coding. Sometimes that's hard. Sometimes that's not easy. Similar with singing. As a choral group, we had to sing together. And I put that up because actually for team-oriented coding together, I actually like choirs and bands and orchestras. They're almost a better metaphor. You hear sports metaphors all the time, and I understand that. But a stronger metaphor is often singing together as a choir, being as one voice and kind of getting together so there's no one person standing out. It's actually the whole group singing. That takes effort. That takes practice together. We'll get back to that. So learn data structures and algorithms. And algorithms is a big topic. Data structure is also a big topic. But if I just had to list kind of, four you really want to get a hold of. Lists, hashes, dictionaries, trees, graphs, and tensors. Fine, I'll call them tensors. The ND arrays. These are different data structures that exist that are, the more you understand about them, the more you can reason with them, the more you think in these data structures, the better off you're going to be. One really cool thing about Python is it comes preloaded with a lot of data structures ready to go. You don't have to sit there with a blank page and go, oh, let me build a class to do something. No, just get started. You got a dictionary. Dictionary is super powerful, by the way. You can do a lot with it just out of the box. You got an array sitting there. If you pull in some libraries, you can get some help with tree structures. And you can build some powerful things just by calling functions on those data structures if you think in terms of those data structures. So really understand what they're for, how they work, and then it's amazing. Life is really fun. You can do it really quickly. So I like to promote array-oriented computing, and I'll have an example of how pulling together interests and data structures and caring what you care about as an example of kind of what this means and how it's fun when these sort of things happen. I put here, there's a bunch of machine learning algorithms. Algorithm is a big topic, and you can read books and books on it. There is no magic algorithm. There's a lot of really good ones. And fortunately, I think coding in the presence of a search engine is amazing, because the search engine you can use iteratively. Iterative searching is the key. Your first search guess is probably wrong because you're talking about it incorrectly. And so you have to use the right words to actually lead to the thing you're trying to learn about. But then you can find out what people have said about some amazing things you can learn quickly. But array-oriented computing is really about, we have a lot of problems today, actually, because a lot of legacy code written by well-intentioned but unenlightened people has created kind of disparate object stores where they have objects scattered all throughout memory. And now you want to have gigabytes of data with objects all stored around memory. Now, if they'd have instead thought about it in terms of array-oriented computing, they'd have collected all that into rows of a table or elements of an ND array. And then you could think generally with array expressions on that huge object. As you do that, now all of a sudden the bottlenecks go away, the lack of, the difficult to think and reason about problems go away. Again, there is no data structure that's a panacea for everything, but array-oriented in data processing is hugely valuable. So definitely something to keep in mind. Another way to have fun in coding is to explore cool libraries. And that's why Python is center to actually do something cool, because Python is full of cool libraries. It's the coolest libraries out there. It's actually why people do stay for the community, that is true, but part of what the community does is produce cool libraries. And so even if you don't like how I dress or the people you meet, all the people you meet in Python are wonderful, you can at least have cool libraries they're producing. There's an amazing thing. Every time I go to a PyCon event, I typically meet one or two people that are people who create these cool libraries, and I'm just amazed. It's just awesome to see it. This is just a very, very short list. There's actually there's a few of these out there. I'm not gonna, awesome Python created libraries out there. Explore your own. Actually, that's a good homework. It's a good assignment. If you're just getting new, want to figure out Python, good. Build your own set of cool Python libraries and see what other people think. There's a few here that are new. I'll highlight Conda. That's going backwards, actually. So I'm going to talk about Conda a little bit because there's still people probably in this audience that still aren't using Conda like they should. I'm very opinionated about Conda, but it's really solved a lot of problems. You still hear that packaging is a mess in Python, and it can be, particularly if you kind of have disparate packaging solutions in your story. That's why it's a mess, and it still is a mess, and maybe we'll get there. Maybe we'll help you keep fixing it. You're not going to fix it by not solving the problem, and solving the problem means having a full dependency tree and full native handling of binaries and packages, and then one thing Conda can improve on is it's a user packaging system. It's not a developer packaging system. It's a system for users to get software installed. But using it, you can get all this wonderful stuff easily. It's an interesting story. When I wrote NumPy, the first version, so it's still, if you download NumPy today, it's 1.23, the 23rd release of the 1.0 series. And embedded in there is some stuff that I wanted to change in version 2. I don't know if the comment's still there, but it's like change this in version 2, right? Thinking that would be, a week, not a week, but like a year away, maybe a year and a half. It's still there, 15 years later. One of the big reasons is because how hard it was for people to get stuff installed. Nobody wanted to upgrade their NumPy version because they didn't want to upgrade the matplotlib and the SciPy and the other packages they'd had on top of NumPy. And it took a week to manage your environments. That's really why we started on Conda. That's how come I, as a scientist, ended up doing packaging for Python, because just getting the stuff installed was a pain. It's actually easier now, but you still have issues around deployment and whatnot. But get all the stuff and make it happen. A little shout out to Fabio and PyScript here too. PyScript's one of the coolest things out there right now. Definitely worth checking out. PyScript lets you write in the browser Python code and have it run in the browser. Super cool, built on some cool technology. But check it out and learn more. Stable diffusion, who's heard of that? Raise your hand. Everybody's heard of it, right? It's all the rage, it's wonderful. I had to get my hand at it, right? Stable diffusion is a Python library. How do you get to take advantage of it? You install Python, but it is fun. It's fun because it gives you kind of a little bit of a hint at what is possible. Here's something I just did. A dog is sitting on the beach next to a dog. Use the Hugging Face interface to this Stable Diffusion. I didn't actually download it on my own system because you have to have a pretty hefty GPU card to run this. And it produced, kind of a dog with a tag, or maybe it's a see-through dog in the middle. I'm not quite sure. But it's kind of interesting that it was just generated that. What's going to be possible with AI is going to be amazing, but it's going to need people who understand it at the core. What we don't need is a bunch of people just shoving out AI solutions with no thinking around it. That'll be actually terrible. We need enough understanding of the models and understanding what we're doing so that we don't let it get ahead of ourselves and do things that we'll all regret. So it's important to learn, important to understand where things come from. But it's a lot of fun along the way. You can have a lot of fun with creation. So here's a little example I'll run through pretty quick. Just this kind of combines array-ordered computing with a cool library to build something that I cared about at one point, right? So this is, some of you may think it's interesting, but I think it's cool. One of the things I like to promote quite often when I talk about NumPy is the ufunc substructure, universal function it's called. NumPy consists of two things, a big array object and then a kernel object, an object that takes fast math. It's actually why NumPy's fast. A lot of people say, oh, Python's slow because it's interpreted. Well, NumPy isn't, because it takes compiled kernels and runs them against large amounts of data. For a long time, I wanted to be able to write those kernels in Python syntax. That actually led to me exploring compilers, and then starting a project called Numba that's now continued by people much smarter than I am, but who have done an amazing job creating a compiler for Python. And now you can actually have this today. You can do a vectorize, that means take a kernel written in Python, and it will produce machine code that then runs across a big array of data. And so when you think about data processing like that, there's amazing things you can do. Now, ufuncs do it element by element. So anything you can think about that will take one element, another element, do some addition, do some math. Generalized ufuncs lets you take regions, lets you take subarrays. So if I can do a matrix with a matrix and then have a big four-dimensional space that's actually doing matrix computation on each one. So the kernels can be bigger. But now with these two, you can actually make it super easy. So that's kind of, okay, I learn about data structures, learn about arrays, I learn how the functions apply to those arrays, and then I can actually use a cool library like Numba to take very simple Python code here. I'm kind of doing the same thing as this calculation, so it's not that interesting perhaps, but it shows the point. So I take some random arrays, and then I do this simple a times x plus b times y. Now that's pretty good. You can do that in NumPy. It's pretty fast. But the way NumPy is written, each of these multiply makes a copy, creates a new array. That makes a copy, creates a new array. then there's a new copy in the end result. So I have multiple copies made, and if you have a lot of data, so big arrays, that's going to be slower because most of your time will be spent creating big arrays, which you may not have a lot of. If this isn't 1,000, but it's a billion, for example, then this is a problem. But you could do this. This takes this operation, and now these are not arrays, these are scalars, even though the expression looks the same, right? NumPy takes a scalar expression and applies them element by element across the whole array. Or I could just here's the element by element calculation. Numba.vectorize will take that and produce a machine code version. They'll just take elements of a NumPy array as fast as you could do it with any hardware. In fact, there's some options to move to GPU hardware and do it in compiled code on GPUs as well, or in parallel. So now that works. Now .2 is faster. Now the speed up depends on how large that number is. And honestly, if you're only 1,000 elements here, you could actually do this in Python and it's not too bad. Like NumPy really starts to mean something when you're about 1,000 to 10,000 elements. And then to actually make things faster, you go 10,000, 100,000, a million, yeah, maybe worry about. You can do a lot with Python as it is. Generalized UFunk's a little more complicated to think about because you have a kernel that's taking an array. So in this case, I have a kernel. This is a little potentially confusing because I think this has been improved in recent versions of Numba, but initially you had to treat everything as an array, even though like I'm just getting a scalar output, it's an array. So this takes an n-dimensional array, an n-dimensional array, that's what the kernel does. Take two n-dimensional arrays and produce a scalar. That's the kernel signature. So here's the two inputs. They're F8s, that 8-bit floats. You tell it what type. And this is the output. It has to be an array even though it's just a scalar. And so now I'm doing this element of x by an element of a by element of x. I'm writing that out and doing the kernel. That kernel will be compiled and then run across the whole array. So I could take this. Now, there's really no equivalent except using einsum. So you can kind of use an einsum, which will do this kind of operation, effectively a matrix multiply in NumPy, or use this generalized ufunc. About 4x faster when I wrote this one about a year ago when I did this experiment. So a lot of computation, very little code. So I thought that was fun. You may disagree, but being able to understand the code, have a little cool tool, build something that I can build a generalized ufunc. And here's the example that I put together. So windowed functions, this happens all the time. You want to take a set of numbers and have them produce this value. Another set produce this value. Another set this value. It's basically what a linear system or a finite impulse response convolution does. Or if I want to do a median, for example, then that's not a linear system. I have to do something else. So how do I do that? Could I do this with generalized ufuncs? And yes, you can is the answer. That was kind of the problem. So I could just do this. This just calculate it with a nested for loop. You know, two for loops kind of all the way across. Every time I have a for loop doing both ways. Or I can build the kernel here, which is just one for loop, and then apply that kernel. And I'll do a little trick here. I'll let you at home work that out. The stride trick, which takes a windowed overlapping one-dimensional array and produces a two-dimensional version with overlaps down the area. So I converted a 1D array into a 2D array, then applied the generalized ufunc kernel over it to get the effect of that strided kernel. Very cool, very quick, very easy. You apply that to four-dimensional image processing to convolutional neural nets, and that's exactly what's happening in a neural net. Convolutional neural nets are doing these little convolutions to get values out. All of it's basically NumPy functions. So then the result is just a filter. So pretty cool. I thought that was pretty fun. So the next point about how to make coding fun, be curious. Dive into things deeply. Be fearless. You know, a lot of people I see, they'll kind of, oh, this is something I don't know about, so I better shy away. I can't learn this. Nonsense. It's all learnable. What's amazing about open source is it's sitting right in front of you. It's only limited by your imagination, your attention, perhaps, and your available time. And those are all difficult things I get. But I wanted to share a story about how did I end up doing all this stuff. I was a graduate student in 1998, just working on my thesis, and there was a guy out there who had shared, his table I/O feature, actually. Go backwards. There we go. His table I/O, Mike Miller, I tracked down his picture at one point. And I wanted to read medical imaging data into the DICOM format, basically. I needed to read it, and I wanted to read it. I couldn't do it. Well, I couldn't put it in a numeric arrays at the time. So I went, I got to build a library to read this stuff in. And I could have done it, lots of different ways, but I didn't know. I didn't know how to build an extension module in Python. I didn't know how to do it. But this guy, he had an example for me. It was called table.io, and I could get his code. I just took his code and said, oh, okay, I see. I just have to make a different function here, call this here, kind of cut and paste programming, which is how the modern web got built initially, right? People just copied websites and built their own. So cut and paste programming is alive and well, and it's fun. So that's what I did. And basically, I had to figure out what reference counting was. Fortunately, you don't have to do that anymore. There's lots of better ways to write extension modules. But Guido had written, apparently just recently, his reference counting essay, and I had read it. And so with those two, I felt pretty empowered. And it was work, and I made a lot of mistakes and errors, but I wrote, and NumPy.io I called it, and released it to the net, 1998. And that was also, I just put it out there. It wasn't beautiful. It was pretty ugly. My web page was really ugly, but people started to download it. And then people kind of emailed me and said, well, hey, you could do this. And I went, oh, this is pretty cool. And it kind of started a lifelong addiction to open source communities, basically. But it was essentially because I was just willing to do it and do something I had interest in and just try to put the effort into. So be fearless. Today, there's a ton of stuff to be curious about. If you're trying to figure out what to be curious about, man, I wish I was alive. I wish I was young today. I wish I was a graduate student today and could just play a little bit. And I had time to just kind of explore stuff. There's stuff all the way, that WebAssembly is really cool. Specifically PyScript, which is building on top of that's really cool. I like LLVM still. It's compiler tools. You can build compilers pretty easily. It's never been easier to write a compiler than with LLVM Lite and the tools that are there. And people are doing amazing things with this technology. There's also, PyTorch. I get to work on PyTorch a little bit, so it's a lot of fun. I like this. We're trying to figure out how to make CUDA programming available for lots of people instead of just one architecture. Linkers and Loaders, a great book. Just learn how linkers work. In fact, combine linkers and loaders with WebAssembly, you got a really cool topic, right? How do you actually load data in a runtime that's dynamic and running in the browser real time? Rethink dynamic linking, right? Stuff that was solved in the 70s with Unix, we can think about that again. So there's some fun you can have. Of course, I loved advanced applied mathematics. There's never a boring moment if you've got that to play with. And so be curious. Tokenomics, token engineering, cool stuff to look in. I'm not talking NFTs, I'm not talking Web3, I'm talking incentive alignment via tokenization. I'm thinking there's actual engineering here to view that's really cool. Posits, if you haven't checked out posits, they're cool ways to do floating point. Those are all things I'm curious about. My final topic about how to make coding fun is to code with a community. The reason Python is fun is because the community's there. You're going to make coding fun if you also think that way. Think about coding together. There's this old African proverb, if you want to go fast, go alone, but if you want to go far, go together. I am living proof that that is how it works. We would not have been able to accomplish everything we've done in this ecosystem without a lot of people who have worked together to make this happen. So I encourage you to do the same. Anaconda, this is an example of Anaconda. I've watched this happen now. That's the one benefit I have, and I'm happy to talk to anybody about the specifics. I've watched this happen both successfully and unsuccessfully, going from early stage working to a full-on community work. Anaconda is no different, going from a few people, hacking together a package manager, because Guido said we had to solve it ourselves, so we did. Then a community internally to Anaconda, then a whole world of Conda Forge contributors who are helping Conda packages get created by anybody. So a very good example. Then I had some fun with this slide. This is just me kind of being a little nostalgic, and this is definitely not all the people, but I wanted to have a few projects that I was deeply involved with and understand that's what made this a lot of fun, is actually working on projects specifically with individuals. And so I kind of had fun just kind of thinking about these people and putting them on this slide. These are people specifically I had a chance to interact with. Not all the people, but a few of them, and I really, really appreciated it all. So from Conda to SciPy, NumPy to start with, and then Numba, Dask, Jupyter, which is a big community of people, of course getting NumFocus started, and then currently we're working on Nabari and Quansight Labs, which is an open source distribution for Kubernetes, basically Jupyter Hub plus Dask plus Conda. How do I have a cluster of machines for data science or any other purpose basically, get working quickly? So it's a nice open source project we're sponsoring there. Very important to work as a community. My experience has been that's how you're going to get most out of your life. All right, so what will you do? Hope you have fun in code. Thank you.
Wow. Thank you, Travis. If you want to say just a couple of minutes
Sure.
for questions, as usual, it's incredible, like how every talk, Travis, it's both inspiring and deeply mind-blowing. You know, it makes very complicated things look very simple. So thank you, Travis.
Any
questions? Don't be shy.
You can track me down later if you'd like. I don't know if you
Yes.
can find me. It's a big place here. I might get lost.
So I will start with one question. So out of the many different problems and complex things that you've done, both from a technical point of view and enabling others to, code and build a community, what was the most difficult thing that you ever had to face?
Oh dear, this is a public gathering. The most difficult thing. I mean, there's different topics. There's technical topics. Like actually writing NumPy stretched me a lot, right? Because I wasn't really in a place where I could build a type system at the time, but I basically needed to. And so I kind of had what I say now is I built a Python 1 version of the type system. I reintroduced a Python 1 type system into NumPy. And just really kind of, but I was happy, I kind of been morphing it. The other thing that was hard about that was actually merging existing communities and getting them to use a package, replace their current work with another package. So merging two communities and having backward compatibility, that was actually a lot of work too, and one of the hard things. I think the people, mostly it's amazing. That's actually surprised me perhaps. You hear all the time about people are hard. Yeah, but not really. I mean, you basically can always just back away, kind of go do some other things and find another way to engage. Like, yes, you're right, people have different mindsets than you, and so you won't necessarily find people who are just going to follow exactly what you want. That's part of the beauty, though, too, is you can build something even better. Usually, and I really have felt that, too, like I've had ideas in my head 13 years ago that I'm glad I didn't do. I'm glad I didn't get my way, right? So I found that even though it's hard at the moment, of kind of like, oh, people aren't doing what I want them to do. If I just take a step back, actually it works out okay. As long as you just seek out relationships with quality people. So there's a few, there are definitely people out there who appear to be, there's certain attributes that you can, that are not community-centric, we'll say. But as long as you avoid that, it's been fine. I don't know, hopefully that answers some of it.
Yeah, thank you.
Yeah.
Question.
Thank you for the wonderful talk. I'm Zoravar from India. So I'll keep it short. I'm a self-taught developer, and primarily I was telling Sebastian a while back, I'm a diving instructor who got into programming, and I'm hooked as of today. It's been a couple of years. So when wonderful minds like yours have brought up or brought out excellent solutions like NumPy, and many others are working on similar academic concepts, I do not possess the applied mathematics or the physics or the science background that you probably had, and as you displayed. Would you say there is a future for self-taught programmers like me to think more about the application of what wonderful minds are bringing together?
Absolutely. Absolutely. Everything has, like most problems, have multiple angles to it. And so it doesn't matter what your background is, as long as you have some things you've been learning and what you have understanding about, you are adding as you bring to the problem. So it's, yes, you don't have to be an expert in science or math and have a big impact. Sometimes it might be a little harder to learn the jargon, because it's definitely true that people use jargon they're familiar with. They assume others have a certain understanding of that jargon as well. That's always a hurdle, and anywhere actually. If people talk about databases, and I've had to learn about compiler theory and learn jargons that I don't understand. But so it takes some effort, but you can always make a contribution. I would say the same thing, I'm not a computer science person, right? Can I make a difference in a computer science field? Same question, really. And yes, you just have to give what you can, keep a mind open to learn, and then try to figure out what just do something. And small and simple things, iterative. You don't have to do, most of the things I've seen work don't all come out at once. It's actually, it sort of emerges as you kind of work on the problem you see in front of you, and then later you can look back and go, oh, that was pretty cool, but you didn't see that entirely from the beginning. You're really working on solving local problems.
Great. Thank you, Travis.
All right.
This was
Thank
great.
you.
If you want to ask more questions, Travis will be around.
Bye,
Thank
folks.
you.